All right, let's jump right in. We're talking about one of the oldest professions on the planet, farming. But what happens when you mix that ancient practice with some seriously cutting-edge data science? Well, you get a completely new way to help secure our global food supply.
I mean, at the end of the day, that's exactly what it is. Every single season, a farmer is basically betting against the weather, against pests, against a dozen other things they can't control. And the payoff? It's never, ever guaranteed.
And take a look at this. This image just says it all, doesn't it? You can have two fields literally right next to each other and get wildly different results. One can be thriving and the other can be struggling. For the person who owns that farm, that difference is everything. And we're not just talking about one person's bottom line here. When you zoom out to a place like Indonesia, where rice is the absolute cornerstone of their diet, this gamble suddenly scales up big time. The success or failure of these little paddy farms can affect the food security of hundreds of millions of people. So let's really dig into this precarious world. What exactly are these farmers up against year after year? First, just wrap your head around the scale. We are talking about the primary food source for 284 million people. That number, it just puts everything into perspective, right? The pressure on every single harvest is immense. The stakes just could not be higher. And the list of risks just feels relentless. You've got pests and diseases that can just decimate a crop. You've got extreme weather, which we all know is becoming way more common. Then there's the constant threat of natural disasters. And all of that funnels down into one core problem. You just can't predict the yield. So, of course, people look for a safety net. And that's where crop insurance is supposed to step in. It's a fantastic idea, in theory. But the way it's been working, well, it's got a pretty big flaw. So the system they use is called Area Yield Index, or AYI insurance. And the idea is actually pretty smart. Instead of looking at every single farm, the insurance company looks at the average yield for a whole region. If that regional average drops below a certain point, everybody who's insured in that area gets a payout. It's really efficient, and it cuts way down on fraud. But that leads to the million-dollar question, right? To set a fair price, a fair premium for that insurance, you have to know what the real risk is. And to know the risk, you need to be able to predict the harvest for that area with some accuracy. And boom, there's the flaw. The old methods just look back at historical averages from the last, say, 10 years. But that's kind of like trying to drive forward while only looking in the rearview mirror. It just doesn't account for what's happening right now with the climate or all the little differences between local areas. It's just not good enough anymore. So, this is where the hero of our story comes in. A team of researchers came up with a new statistical model that was designed to solve this exact problem. Okay, it's built on something called the four-parameter beta distribution. I know that sounds super complicated, but the idea behind it is actually brilliant and simple. Think of it like this. A normal model trying to predict a test score might give you a crazy answer, like someone could score 150%. This smarter model knows that's impossible. It knows the score has to be between 0 and 100. It does the exact same thing for crop yields. It knows there's a minimum and a maximum. It keeps all the predictions grounded in reality. So here's the real difference. The old models, they assumed infinite possibilities. They didn't have those realistic limits we just talked about. This new model, called a GLMM, knows that yields are bounded. And this is the really cool part. It uses what are called random effects to basically customize the prediction for the unique conditions of each little subdistrict. That makes it incredibly local and way more accurate. But, of course, a great theory is one thing. To see if this thing actually worked, the researchers took their powerful new model and put it to the test in a real-world case study in central Kalimantan, Indonesia. And they followed a really rigorous scientific process. They started with a theory, then they collected a ton of data, then they built the model, and finally, they put it to the test to see what it could predict. And this right here, this is what's so cool about their approach. They didn't just use one kind of data. They combined what they call ground truth, which came from detailed surveys with 534 actual farmers, with a super high-tech view from space using satellite imagery. It's really the best of both worlds. So from the farmers on the ground, they were getting these crucial details. Stuff like how they managed pests, what kind of fertilizer they used, and if they had enough water. Then, from the satellite way up in the sky, they were measuring light spectrums, like infrared, to calculate something called NDVI, which is basically a plant's health score seen from space.
Okay, so here's the payoff. What happens when you feed all this rich, complex data from the soil and the sky into that really smart new model? Well, you get a clear, actionable number.
But first, the model showed them something fascinating. The data was not a perfect bell curve like you see in textbooks. It was skewed. What that means in simple terms is that most farmers' actual harvests are lower than what a simple average would make you think. The old insurance models would get this totally wrong, meaning they were underestimating the risk for the majority of farmers.
And that insight leads directly to this. The model calculated a fair, data-driven insurance premium, somewhere between 300,000 and 410,000 Indonesian rupiah per hectare. Now, this isn't a price based on some blurry snapshot from the past. It's a price based on a high-resolution picture of the real, actual risk right now.
So why does one study in central Kalimantan matter to the rest of us? Well, because the implications here go way, way beyond a single region or even a single crop. What these researchers have really created is a blueprint. Think about it. In a world that's facing more climate change and more uncertainty, we desperately need our food systems to be more resilient, more responsive. And this approach, it shows us exactly how to do that.
I mean, the conclusion from the research paper itself just says it all. This new method, quote, delivers greater precision, responsiveness, and flexibility. It's not just a small improvement, it's a fundamental upgrade on how we manage risk in agriculture. And that just leaves us with this huge, fascinating question to think about. As our technology gets better and our ability to analyze data gets even more powerful, you have to wonder, could this blend of eyes in the sky and intelligence on the ground be the real key to taking the gamble out of farming and securing how we feed our entire planet?